So far when we looked at solutions, we looked at how they formed and how much could dissolve and what things did dissolve and what didn't dissolve. Today we're going to look at a completely separate question. If something dissolves, how fast does it dissolve? And what can we do to make it dissolve faster? Because the things that we do to make things dissolve faster are the same kinds of things that make every reaction faster. And that's where we're going with that. So, one of the ways, if you wanted to make something dissolve as fast as possible, think about what you would do to it. If you needed some punch made really quickly, what could you do? Well, one of the things you could do would be to choose the right stuff. Okay? If it's polar, nonpolar, or ionic determines how much will dissolve. Well, the answer is 0 or a little bit or a lot. Depends on whether the solute and solvent are polar or ionic. Okay? It'll decide whether it will dissolve, because sometimes the answer is 0 will dissolve. But if I want something that does dissolve, if I want it to dissolve faster, I can stir it or shake it. I can use smaller particles. So instead of sugar cubes, I can use crystals of sugar. Or if the temperature's increased. So if I want to make Kool-Aid really fast, I should stir using powdered sugar into hot water. That would make my Kool-Aid the fastest. If I just pour the sugar in, if I put cubes of sugar in or pieces of candy in a container full of water, and just set the container full of water in the fridge, eventually that candy would dissolve, but it would take forever. Okay? But if I did the same thing with powdered sugar in hot stirred water, it would dissolve almost as fast as you poured it in, until you reached a point where you couldn't dissolve anymore, and then you'd be saturated. So why? Why do each of those things make a difference? Okay, why does stirring make a difference? Well, in order to dissolve, the solvent molecules must touch the solute. Remember, the water has to grab onto the ions and pull them apart. Water has to pull harder than the solid does. So they have to touch each other first. And they can because that's how they're going to hold on and surround the solute. What stirring does is, well, you think about it. The solute's sitting there and a solvent comes and picks it up. So now you've got this dissolved piece. But that water that's hanging on to the dissolved piece can't grab another dissolved piece. It can't get a second one. So in order for you to dissolve the second piece, you got to get the first water out and its pieces out of the way so you can get water that's not hanging on to stuff to pull the next one. And that's why stirring makes it dissolve faster, is it's bringing solvent that's not holding things next to the pieces. That's what stirring does. Okay? Particle size. Candy versus powdered sugar. Why does it make a difference? Well, because if they touch, the only place they're going to touch is on the surface of the solute. And the smaller the piece, the bigger the surface area. Okay? Let's see if I can draw a diagram that shows that. Okay? So, if you had a cube of salt crystals, the only place you can dissolve is here on the surface. But if I take and cut this in half, now I have two whole more surfaces that can touch the water. That surface there, and its partner on the other one. I can't draw a 3D. So it's just this. 3D drawing is not my strength. But this whole surface area here and its partner there would be exposed. And the more times I crush it, the more surface area I expose, the more places they can touch. And if they touch more often, every time they touch, they have a chance of ripping those solute molecules off. So the more often they touch, the faster it goes. So smaller particles dissolve faster because they have a bigger percentage of their molecules or their solute pieces at the surface. Temperature. I mean, I like drinking iced tea in the summertime. There's two ways to make iced tea. One's fast, one's slow. I can either take the tea bags and put them in boiling water, and that makes my tea really fast. Or I can take those same tea bags and put them in a container full of water and sit them on the windowsill. Eventually I'll get sun tea, but the tea dissolves into the thing. It just takes a lot longer. Why? Well, because remember what temperature is. Temperature is motion. So the higher the temperature, it makes the molecules move faster. And the solvent's going to move more, and it's going to run into the solute more often and harder. So the more often it hits it, the more often it grabs it, the more often it's likely to take a piece off. So more pieces are broken off and carried away, and it speeds up dissolving. It's also, I mean, you can see temperature as stirring without moving your hands. Okay? That any solute that gets dissolved is going to be moved away from the surface so the next one can be dissolved, exposing more surface. So if you raise the temperature, things dissolve faster because you're moving the solute around. Now temperature is the one that affects how much. Stirring won't affect how much. Particle size won't affect how much. But temperature can affect how much. For most solids, it increases the amount, and for gases, it decreases the amount. We talked about that last week. So choose all that apply. Pause here and think about what you get for those answers. So which of these would make it dissolve faster? Okay. So the liquid is heated. If it's heated, oh, my pen doesn't want to work. Oops, go back. If it's heated, the particles are moving faster, they're going to carry the solute away, that's going to make it faster. If the solid is in large chunks, then the center's not available. If the center's not available to touch the solute, it's going to be slower. If it's stirred vigorously, bring solvent to it, it's going to dissolve better. If the solid has a large surface area, that's lots of places to contact. Mixtures put under pressure. Did we mention pressure at all? Well, pressure is collision of gas molecules, but these aren't gas molecules, so pressure actually has nothing to do with how fast. It has to do with how much if it's a gas. And if the solid is polar and the liquid is nonpolar, this is going to decide whether it dissolves. It doesn't decide how fast it dissolves. We wouldn't expect it to dissolve, but it doesn't talk about how fast. Okay? So if they were both polar, it wouldn't talk about speed. If they're both nonpolar, it wouldn't talk about speed. The issue is polar and nonpolar decides whether it dissolves. These other factors affect how fast. We'll talk more about rates along the way. A few quick read guide questions for you. Have a great afternoon.